Good evening, everyone. Thank you for joining us tonight. My name is Gihad Barakat. I'm working as a program manager for the AI bootcamp at WeCloudData. And today we are delighted that we have Sumia to be our expert, that we are going to invite her tonight to speak more about the generative AI in the field of NLP. Sumia, she has more than a decade of an experience in research for industry and different research organizations. Her main focus in the research is in natural language processing, and also she published one of the commonly known books in that field, which is practical natural language processing. So if you are interested in learning more about the natural language processing, I would recommend you to get this book and to try to learn more about this field. So without further ado, let's start with Sumia. So tonight we are going to have some points to discuss, and feel free to ask the questions whenever you have any of them. It's going to be more an interactive talk. So whenever you have any questions that pop up to your mind, feel free to open your mic and start to ask your questions after raising your hand for sure. Thank you. Welcome, Sumia. The floor is yours now.
Thank you, Gerhard. Hello, everyone. So we just have a few leading questions for the discussion, and you can feel free to interrupt me at any time. So there are a few slides. Like for each slide, I'm going to talk a little bit about the topic, and you can ask any questions that you have on that topic. So we are starting with key developments in generative AI related to NLP, natural language processing. I'm sure you already know what generative AI is, and you have some interest in the topic. Otherwise, you won't be here. So natural language processing is all about working with human languages, processing human languages, understanding them, and performing various tasks with human language interaction instead of, say, programming language or something like that. So we see, NLP being used in all sorts of use cases, like business use cases, like say chatbots or even day-to-day applications. You use your phone and you have this voice assistance, or you use your email, you have this a lot of information extraction from emails, or text categorization of emails into spam or not spam, or different categories in Gmail. So like NLP is everywhere, basically. So when ChatGPT came last year, a new kind of NLP, which is based on generative models, became more popular. So generative AI is all about using AI to create new stuff, like an AI that writes its own stuff, an AI that can write an essay by itself, or an AI that can generate an image by itself, or well, I mean, by itself. When I say by itself, I mean in response to human prompt. Or we are even seeing video generation and audio music generation and these kind of things. So what are the key developments in generative AI related to NLP? So in my view, in the past 1 year, after ChatGPT, there has been a lot of research into the development of other large language models, open source language models, which some of the open source language models are specific to a domain. Like say there was a Bloomberg GPT, which was very specifically trained on financial domain. And then there has been some interest in developing small language models. So now we also have small large language models that you can actually run on your laptop if you want, and do text generation just on your laptop. So that has been one thing that was not possible, like say a year ago. The models were still big, and you needed some GPU even to do some inference on the model. But now we can do some stuff even on our laptop if we want. And there has been a lot of interest in, so what made ChatGPT suddenly possible was something called reinforcement learning with human feedback, that is with learning from human preference data. I'm sorry, I lost. Yeah, reinforcement learning with human feedback. So what that means is like when ChatGPT was released, it was trained on massive amount of human preference data. That is, you give, sorry, it what it was doing good at was generating more natural sounding output, human-like output, and that was because it was trained on human preferences, like by something called reinforcement learning, which has a reward model. And that has been like, you can talk about it as like some kind of a turning point in this kind of research in NLP and generative models. But there has been some advancements over that as well. Like there has been some work on, why should we use human feedback? How about using AI feedback? So reinforcement learning without human feedback, like with AI feedback. And there have been some other developments like, why should we have reinforcement learning at all? We can get away with reinforcement learning, but still learn from human preferences, which is called direct preference optimization. And then there are other methods of that kind. So these are all the kind of things that have been that have been ongoing. And there has also been like a lot of work into how to deploy these models, say in a GPU environment or in a GPU constrained environment. Like there are a lot of new libraries that came up around this thing. Like how do you use models to make to make inference, but then you don't have like a bunch of GPUs sitting there. And there has been other work on how do you combine different models, like it's called mixture of experts. And then there has been research on, how are you training these models? Like what kind of data are you using to train these models? So these are all like many different kinds of things that have been happening within generative AI related to NLP. Of course, I mean, I can like, it's possible to talk more, but I just wanted to give a more general overview of what's going on. So yeah, I mean, if you want to ask any questions or something like that, please feel free to ask. Yes.
Hi, thank you for presenting. I was wondering if this has any intersections with quantum computing. Maybe it could help with memory or resource allocation.
So I've read about how quantum computing can help generative AI in terms of like resource management and in terms of how handling these massive computations basically. But I haven't come across anything the other way around, like how can generative AI help quantum computing? And I don't know much about that area to make some speculation on that.
Hi, this is Kawaljeet. So how do we choose between which LLM or which model is right? Basically, if I choose between Bedrock or Llama model or any other Google, so what is the right? Because Bedrock has a lot of models. Let's say we can use LLM Claude V2, or you have a Titans. Similarly, what is the right mechanism? Nowadays, what happens is across different clouds, they came up with, like, OpenAI has its own way of doing RAG model or content summarization. So what is the right approach? What are the parameters do we choose to find that the LLM or model, foundational model?
Okay, so it's an interesting question. It's a very valid question, but in my opinion, there is no one right way. It really depends on your task and your data. Like however large a model may be, however famous a model may be, if it is not working for your data, It's just not working for your data. It's not for you. So a general procedure is have some kind of test data for your problem situation. Don't start without any data. It need not be huge. Like like let us say you are doing some kind of I don't know, topic classification of all documents in your organization or something. At least have like 5 or 6 examples per topic, and then try out different providers options. And it's not guaranteed that one provider will always do well. Although when you look around, people may say OpenAI always works, GPT-4 is always the best. It's good, but it need not be the best for your situation, right? And you may be looking for something that's maybe faster, or that's maybe more private, or things that you can host locally. And the cost may not be effective for you in the long run. So I would say, like, there's no single solution. Like, I would suggest you to evaluate at least 3 or 4 options. They need not always be like this big proprietary LLMs. There are also some open source models that are comparable. Yeah, so you have more questions?
Yeah, I think.
Yeah, like I see a raised hand again. That's why I asked you.
Yeah, no, I have. So I didn't want to ask multiple questions because there are a lot of audience, but just
Yeah,
to
that's
follow up
fine.
question, I think this
Yeah.
was a valid answer. I have worked on Bedrock as well as Llama, so I was under the same impression that it depends upon whether you're looking for cost efficiency or there is a huge, you have a bigger input, then you go for Llama 2.7 or 70 billion, or if you have some other aspect of your data or requirement, then you switch your basically, and then how much prompt engineering required. So the second question I have is the vector database, which is a very, like, nowadays Pinecone, there is a, AWS has different open
Yeah.
search. So I did some, I was part of a pilot project, so we did use that. So can you help us? What is the nuances of vector database to choose? Like, because there are a lot of many in the market. So based on your experience or based on your research, what is the low hanging we should go for to meet the minimum criteria or to meet at least the basic criteria?
I don't actually have any experience with the proprietary vector databases. Sorry about that. We've been generally using Lucene style search implementations. Elastic also has Elasticsearch also has a embedding based implementation. So that's what I've used. I don't have experience actually with Pinecone and stuff.
We have another question on the chat. So Darren is asking, I have understood that the reason that NLP like ChatGPT provides a much better response because of the size of the data consumed. Is this not correct? By better, I mean more accurate. So
yes, to an extent it is correct. But what do you mean by better response there? Like when we use the ChatGPT interface, the free interface, you ask a question and it gives you the answer. So what is better response there? I mean, it can also be wrong, right? Uh, uh, we've seen enough examples over the past 1 year of ChatGPT giving wrong references, and even these high-profile cases of where a lawyer looking at ChatGPT and getting some reference and finding out that that case never existed. So having more and more data, training on a large amount of data makes ChatGPT produce fluent text and be able to do certain tasks well. Like, say, for example, talk about a code, like you give a description and it will produce a code, or you ask a question and it gives an answer, or you ask it to write an essay on a topic, it comes up with a well-phrased sentence. So the kind of tasks which can be learned with massive amount of data by like the next token prediction task, that is the way they learn it. So so I would not think it is more accurate. I would say it's more fluent, which is not necessarily accuracy.
that's a really good point. It's more fluent, but it doesn't have to be accurate. That's a very good point. Yes, for sure. Okay, so yeah, let's go for the next point.
Okay, yeah. So in terms of the market trends, based on what I've been following, people have been, talking a lot about retrieval augmented generation, which Kawaljeet also asked about. Like there's a lot of talk about because large language models, when they generate text, are prone to hallucinations. They are known to produce inaccurate texts. So to mitigate that problem and to also insert some kind of domain specific documentation into large language models, like there is a lot of work in that direction of using this kind of retrieval augmented generation setups. And there is also a lot of work on using large language models for programmatic data labeling, that is automatic data labeling. There is a company called Snorkel, if you are not aware of it already, which does a lot of work in that direction, where they talk about, so even with a language model, if you want to use it for your specific purpose, you may need some kind of manual labeling. But doing large amounts of manual labeling, even for our purpose, is expensive, right? So what the Snorkel follows some kind of a approach which they call programmatic data labeling, followed by learning with programmatic data labels. So that is also something that I see frequently up in the, like even today there was a post by Snorkel saying their approach is on top in one of the LLM evaluation leaderboards. So and there is also like I mentioned even before, there is also talk about combining different language models. So in terms of applications, like there are applications that were not really possible before or not really very accurate before, like applications focusing on generation. Say for example, a couple of years ago, you would not have thought about startups like Jasper or things like that, which helped you with writing different kinds of stuff. And like there are new features like in Khan Academy and things like that, where you have these features that are based on GPT-4 and recent language models that enable more personalized feedback for learners. Uh, uh, Personalized, and there is also a lot of work on personalized pronunciation tutoring and these kind of things, like in the language learning and technology space. So these are all new applications that were not possible before. And within the existing businesses, existing use cases, the switch from building your own models to from the scratch using traditional NLP methods to leveraging existing LLMs somehow, either as some kind of off the shelf uh, predictors, or as some kind of labelers which can be then used to train your own model, some kind of data creators. So these are all some kind of trends as that I know, like I know of, and of course there may be many other trends, especially I'm still talking about when working with English text and English data, but I'm sure in various other markets where it's multilingual markets, there is also a lot of increasing use of other languages compared to before, because some of these large language models, although they don't explicitly mention they are multilingual, are capable of responding in multiple languages, are capable of generating multiple languages. I'm not saying all possible languages, but some, like say for example, there is a model called Mixtral, a mixture of experts model, where there are 8 smaller models that they, like at the outset in the documentation, they specify that they can do well in 5 languages. So uh, that's also something like a growing trend. Yeah, I guess I don't have anything else to add there. Okay, there is one raised hand from Kawaljeet.
Kawaljeet, do you have another question?
No, sorry, I'm good. Actually, it was the last time.
Okay.
Thank you.
Okay, so yeah, let's go for the next point.
Okay, so research and industry challenges and opportunities. So this is again related to the first point that we talked about, right? Like in terms of the general trends. So when we talk about, say, this mixture of experts or removing the reinforcement learning part or things like that. So these are all challenges with using large language models in practice, and so then research started coming into those topics. And in terms of opportunities, I think there is in terms of research opportunities, like one area where there is a large interest in all sorts of like government bodies or other research organizations is how do you evaluate the robustness of this kind of large language models, and how do we, how can we make them stronger? So far, like there is a lot of research on how do we make them produce less harmful content, less toxic content, and how will large language models follow your instructions and stuff like that. But on the other side, it's like if you want to use these kind of models in actual applications in say in some kind of military scenario or in some kind of a cyber security scenario, there more questions will arise. Like, how do you ensure that these large language models are secure? How can we make sure that, a random large language model we download from Hugging Face or somewhere, it's safe? It can itself be an attack, right? Like, I mean, you download a model and then the model itself can be, whatever. So how do you make sure the models that you're using are secure to be used in this kind of setups? And how do you make sure the models are robust to your application scenario? How can, if they are not, I mean, if you find out from some tests that the models are not robust to certain kind of scenarios, how do you make them more robust? So I think these are all like interesting research challenges, both in research and industry and government especially. And there are a lot of opportunities in that direction, along with talking about how to make the model smaller, how to serve them like with fast inference and stuff like that. Thanks for sharing the link, Alexandra, in the chat. I'll check it out after some time. Yeah, this is relevant to what I just mentioned. Like, how do you know what your model is doing, right? Like, is it safe? Okay, any questions before we get to the next point? Okay. So how do we get ready to join the market in this scenario? So I read something earlier this week in a newsletter called The Sequence about how the roles around generative AI projects, changed compared to before. So a few years ago, these roles, like there were roles like AI engineer or some NLP engineer or these kind of things, which are separate from regular software engineers because they focused especially on these kind of problems. Like, say NLP engineer probably knew how to train a language processing model for like a text classification model or build I don't know, machine translation system or something like that. But with the growth of these large language models over the past years, 1 year, the way we interact with the system changed, right? Like we are prompting the system. We don't need any special expertise in a sense to prompt a system to do a task. So I've read that those kind of roles, like those specialized roles, are probably diminishing, and maybe somebody like a full stack software developer or somebody will be able to get into development of a NLP system, for example, instead of having somebody who is specializing in NLP. So in that, I mean, if that is true, if that is the scenario, then I think people should focus on two kinds of skills at the same time. On the one hand, having good development skills, like software development skills, but on the other hand, having more knowledge about the domain and having more knowledge about the different kind of like problem solving. Basically, like if somebody in your organization, in your company comes up with a problem description, we should be able to map that problem description into a step-by-step process of how to solve the problem, and that together with your software development ability and the ability to prompt the language models to do what you want them to do. I think a combination of these things is what is needed to get ready to join the market. And of course, we need to be prepared for an ever-changing scenario. Like as researchers, for us, we used to think that what we do right now, like in 6 months later, maybe it's irrelevant and somebody else is doing. But right now, it's like you do something and 2 weeks later there is some new large language model coming up. So it's evolving at that pace. And at some point it will stabilize, but if you want to enter the market right now, you also need to keep track of, at least you need to know what is happening, right? Like you may not be an expert in everything, but along with the skills that you develop, like say software engineering and problem solving, you need to also follow what is going on, both in research and practice, because there is like the line between research and practice is getting blurred in that particular area for large language models. Like a few years ago, they were more separated. Like even within big companies like Google, there were research teams and there were product teams, like and people work on research problems. But then there will be like some time between research getting into actual products, but it seems to be getting very less now. So people who are trying to get ready to join the market right now, they even have to follow the research developments, which probably was not the case a few years ago.
We have another question on the chat.
Yes, we have a question from Sinem. What about the healthcare opportunities for paralyzed patients and privacy concerns? Wow, the first part is like very specific. There are, so I don't know the answer for that specific use case, like that specific group of people, but there are there is a lot of work on how generative AI models can be useful for healthcare in general. And there is also work on how speech impaired people can benefit from generative AI models, or and not just language, like other kind of generative models. There are, of course, a lot of privacy concerns. It's some kind of an ongoing research topic. Like there are privacy preserving language models. Like that's an active area of research, and using small language models that you can host on your own, or stuff that can work on, say, your personal devices. So these are all like ongoing areas of research. So I don't have like specific answer for paralyzed patients as such, but I can say that people are working on these kind of topics. So we have one more question from Alexandra. Is Python the best language to leverage in terms of engineering? Python, I would say, is the most supported language for people who are just starting out. So if you want to get into core engineering, like there is also a growing interest in using Rust, or where people used to use C, C++ in the background and have a Python wrapper around it and stuff. But otherwise, yeah, like I mean, a lot of these models have some kind of a Python library interface, and it is easy to use them. And even in a larger software setup where your actual development is happening in, say, a C# or something like that, for the NLP part or for the machine learning part, it's common to develop something with Python and then expose it through an API or something, and that application in C# or whatever language calls this Python application. That is, this part is separated from the overall application. So this can still be in Python, and the entire application can still be in whatever language they're developing. So yeah, I mean, it's still like you need to know Python to get into these kind of things. Yeah. Okay, yeah. So those are all the questions that we had in the slides. So feel free to ask if you have anything else.
All right. Thank you, Samia, for the interesting discussion. Also, it was very inspiring and insightful for me for too many levels. So if you guys don't have any more questions, I can just share with you learning opportunity that we are offering right now at WeCloudData. So right now we have machine learning engineering bootcamp, which we are going to start soon, within less than 1 month from now. So in this bootcamp, we are teaching more about generative AI. We are starting from the fundamentals of the AI, like neural network, deep learning, computer vision, NLP, and large language models. And then we go towards the model deployment, how you can handle model deployment in terms of what's the best machine learning infrastructure to be used, how to learn to deal with different tools like Docker, Linux, how to do deployment on cloud using AWS, utilizing SageMaker, Kubernetes for your model. And then we are having another modules for model engineering, how you can learn how to use MLflow. And we are practicing more of software engineering concepts in terms of the machine learning world, how to utilize different software concept and software deployment concepts and technologies in the machine learning. And finally, the whole operations for the machine learning. And after completing this, we are offering different opportunities for career preparation and mentorship. Like we are offering real-time projects. So our students working with real companies, they are trying to solve real business cases with the support of mentors and technical team to support them to get the project done. And this has helped a lot of our graduates to get ready for the market. We are going to start February 22nd, and this diploma is in a part-time mode. So we just work on Thursday evening and Sunday full day, and it's expected to be done within 6 months. So if you are interested, I'm going to share with you the link over the chat. You can just review the material that we are offering. If you are interested to join us, maybe you can sign out the form, and we will be in touch with you to let you learn more about the opportunity, what it costs, and all the questions that you might have regarding this this opportunity. So thank you for joining us today. It was really a pleasure having you, and thank you, Soumya, for your insights and for the discussion as well. So right now, if you don't have any more questions, so please feel free to leave the sessions. Otherwise, you can stay and ask if you have any other questions. Thank you for that. All right. It seems that all the questions have been answered. So thank you for your time, Sonia, and thank you everyone for joining us tonight. Hopefully you have a lovely night and see you in our next events. Thank you all. Bye-bye.